Hey everyone, a few weeks ago my vlog about water on Mars sparked some interesting conversations, including about potential future habitability on other celestial bodies. So today let's shift our gaze a bit closer to home and talk about water on the moon. Okay, so when we look at the moon, we don't see any oceans or rivers, but there's more to lunar wetness than meets the eye. Recent studies using data from NASA's Moon Mineralogy Mapper have revealed that our celestial neighbour is hiding quite a bit of water and hydroxyl molecules. These aren't just concentrated at the poles, as we once thought, but are spread across the lunar surface in various forms. Let's break it down. We've got water ice hiding in permanently shadowed craters, water molecules trapped inside rocks, and even hydroxyl molecules, that's oxygen and hydrogen bonded together, scattered across the lunar soil. Now, how did all this water get there? Well, it's a combination of factors. Some water-rich rocks were excavated by meteor impacts. Solar wind interactions create hydroxyls on the surface, and volcanic activity in the moon's past might have brought water-rich materials up from below. Well, here's where it gets really interesting for future lunar exploration. The moon has different types of rocks, and some of them are surprisingly wet compared to others. This means future astronauts might be able to extract water from these water-rich rocks, even in areas near the lunar equator. It's not just about the ice at the poles anymore. We're talking about potential water sources across a much wider area of the moon. Of course, getting that water won't be a walk in the park. We'd need to heat the rocks or trigger chemical reactions to release the water. It's not as easy as scooping up ice from polar craters, but it could provide a valuable resource across more of the lunar surface. This discovery is huge for potential future lunar bases. Water is essential not just for drinking, but also for producing oxygen and rocket fuel. Having multiple sources of water across the moon could make long-term lunar habitation much more feasible. As we continue to explore our solar system and search for potentially habitable environments, understanding the distribution of water on nearby bodies like the moon is crucial. It not only helps us unravel the moon's geologic history, but also paves the way for future exploration and possibly even colonization. The next time you look up at the moon then, remember there's a lot more wetness up there than you might think. It's just another reminder of how fascinating and full of surprises our cosmic neighbourhood can be. Thanks for watching through to the end, and don't forget to subscribe for more astrobiology content.